I believe the moon not to be smooth and polished, like many philosophers believe it to be, but is in fact rough and uneven, covered everywhere with huge prominences and deep valleys and chasms. Perhaps other things more remarkable will be discovered by such an instrument as the telescope. Galileo Galilei, March 12th, in the year 1610. The telescope has been the main tool in the past 300 years, starting with Galileo for observing the moon, being evident from the beginning with observations made by Galileo in discovering two main types of topography on the surface of the moon. First, there is the dark, smoother parts of the moon that can be seen with the naked eye called Maria, and then there are the highlands, brighter and heavily cratered areas that surround the Maria. Observing with telescopes from Earth, we can see an area clearly no larger than a large football stadium, say, because of trying to see through Earth's turbulent atmosphere. To get a closer look, we needed to wait for the advent of space probes. And with the aid of space probes launched at the moon, we discovered that even with the smooth Maria regions, there were craters. The moon rocks retrieved gave us a better understanding of the processes that happened on the moon, compared with the processes that happened on and within the Earth. Having obtained these rock samples from the moon has finally answered long-held questions about how did the moon form, and how with the obvious differences with the formation of the lunar highlands and the lunar Maria. So what did we find out? What are the processes that shape the two different surfaces that we see on the moon? Was there ever any water at some time in the past on its surface, or any forms of life that had developed? The final overall question is, why is the moon so different from the Earth? A rock seen here, picked up from an area on the moon called the Ocean of Storms, was found to have a texture of quickly cooling magma, with long grain-shaped feldspar crystals mixed within its matrix. This moon rock is very similar to the quickly cooling magma rocks here on Earth. Magma, just like on the moon, coming out of the crust of the Earth onto the surface and cooling rapidly. You may wonder, how can we be so positive of how these lunar rocks formed, when obviously no one has ever seen one before? Well, we already know a great deal of how many different types of rocks formed here on Earth, so we can then apply that knowledge to learn how rocks formed on the moon. This rock I'm holding comes from an ancient lava flow here on Earth. Taking a closer look with a hand lens at this and other similar rocks found around the world, we can see the size of the crystals are too small to be seen even with a hand lens. Usually when small crystals are seen in a rock like this, it tells us that this type of rock cooled very rapidly upon reaching the surface. And that's what exactly happens within the rocks of a lava flow. A lot of lava rocks found have holes in them called vesicles, where gases within the rock has escaped while the rock was molten. We have found many rocks with these same vesicles that come from the Luna Maria, so we can be pretty certain that this moon rock found had a volcanic origin just like the ones from Earth. Besides these techniques of examination, there is another where we can make thin sections of the rocks that can be examined under the microscope. Here we can see a earth lava rock's crystals under the microscope, showing the elongated shaped crystals with gray and white stripes of a mineral called feldspar. And here we are looking at a lunar rock sample from the Maria. We can also see elongated shapes of feldspar crystals within this sample, just like the rock samples from Earth, telling us that both samples of rock examined from the Earth and the Moon have a volcanic origin. So looking at the Maria on the Moon, we know that the Maria are vast ancient lava beds that flooded large portions of the Moon's surface. When a meteor slams into the Moon's surface, it does so with tremendous force. The force of the impact creates not only a crater, but cracks and fissures within the crust of the lunar surface. Upwelling of magma from the hot molten interior of the young Moon spills out over large areas of the Moon's surface, creating the Maria. Of course, knowing what a rock is made up of tells us next to little of when it was formed, its age. To find out the age of the lunar rock samples that were brought back by the Apollo astronauts, they were painstakingly analyzed in the NASA laboratories. NASA scientists discovered that the oldest lunar rocks were 3.9 billion years old, and the youngest around 3 billion years in age. Determining the age of the rocks from the lunar highlands was more difficult, compared with the Maria rocks, based on the more complex processes of the formation of these rocks. Here, we are looking at a lunar rock sample from the highlands. With even the naked eye, we can see the difference compared to the finer grained volcanic rocks seen earlier. This type of rock is known as a breccia, the word meaning broken. Under the microscope, it can be seen as a type of rock made up with a whole bunch of jumbled and jagged pieces of different types of rock, held together by a dark material. Even within the individual fragments within the rock sample, they are full of cracks and fractures. The cause of the formation of this type of rock is from meteors slamming into the Moon's surface at a velocity many times faster than a rifle bullet. Each impact throws up in all directions from the point of impact large amounts of rock. A lot of this rock melts from the energy of the impact that creates intense heat. Solid rock fragments within these impacts mix with the melted rock and then cools, forming the breccias. Another type of rock seen here in this lunar sample is a type of rock called anorthosite. This type of rock is also found here on Earth. By already knowing that this type of rock came from deep within the mountains of the Earth and cooled more slowly, having larger crystals within its matrix because of this slow cooling, it tells us that the lunar anorthosite rocks from the lunar highlands formed in the same way, occurring alongside the breccia also found in the highlands. It also tells us that these anorthosite rocks from the lunar highland means that the highlands are older than the Maria. NASA lab analysis has found that the highland rocks are in age to pretty close to when the Moon was formed. So, when looking at the Moon with the naked eye or through a telescope, we know what we're looking at with more information in our heads. The highlands of the Moon are the battered remains of the most of the original or close to the original surface of the Moon, filled with breccias and anorthosites type of rock. The Maria are a later stage in the Moon's surface that we see today, formed by the upwelling of magmas through the cracks and fissures of meteor impacts out onto the surface of the Moon, covering vast areas of the Moon's surface. Wouldn't it be a wonderful thing if Galileo knew the other half of the story of the Moon when he first looked at it with his telescope?